Okay, here is the functions practice test key. Number one, which equation is not a function? What you could do is you could graph every single one of these in your graphing calculator and then perform the vertical line test. So as you can see, I've drawn all the graphs, and the only one that doesn't work out is number 4. It is a circle. So the vertical line test would go through twice, and it would not work out. The answer is 4. Another way you could do this is by just looking all the y values. You can see that we have first power, first power, first power. This is the only one to the second power, showing that you know it's going to be some sort of circular or like an oval shape. Number 2, what is the domain of the function f of x equals 3x squared over x squared minus 49? So remember, the domain definition is all the possible values of x. So in the numerator, you can have any x possible up here, right? But the thing about a fraction is that a denominator must never be 0, because the golden rule of mathematics is you cannot divide by 0. So you ask yourself, what values of x will result in a denominator of 0? So what we do is we set up basically the expression in the denominator, x squared minus 49, set it equal to 0, and solve for x. As you can see, it's positive or negative 7. So this basically means for all values of x, x is in all the real numbers except for positive and negative 7. Okay, just like number 2, number 3 wants to know the domain of this function. Now this function here is under the radical. And if you remember, you can take the square root of 0 and up. You really can't take the square root of a negative number, because your result would be an imaginary number. Remember the letter I, right? So this is an imaginary number. It is not a real number. So whatever x value produces an imaginary number is really not allowed in the domain. So you really have to ask yourself, this expression will evaluate to 0 under what x values. So what you could do is basically take x squared minus 4x minus 5 under the radical and set it equal to 0, or actually it's an inequality, greater than 0. You know this must be greater than 0 or equal to 0 for it to be a real number. So what you do is, fortunately, you've already learned this skill, right? How to solve a quadratic inequality. So what you do is you factor the trinomial. Fortunately, it works out nicely. It's x minus 5x plus 1. You find the roots, 5 and negative 1, and then you come up with your test cases, your intervals. You put it on the number line, and when you plug in, say, 0, you end up with negative 5 times 1, which is negative 5. Now, is that greater than or equal to 0? No, it's not. So we end up with false in the middle, and that means the left side, everything negative 1 and less, is true, and the right side, everything 5 and greater, is also true. So your answer is option 2. Now, what does all this mean right here? Basically, it means this is interval notation. So this parentheses means that it's basically negative infinity up to negative 1. And the square bracket means including negative 1. That's why this is a filled-in dot. The U basically means union. Okay, so it means all these numbers and all of these numbers. And 5 up to positive infinity is basically shown here on the number line. 5 up to positive infinity, and this is a filled-in dot, and that's why we have the square bracket here. Oops, that didn't work. And the square bracket here. All right, number 4, replace x with a plus h, this expression, and simplify. So you're basically taking f of a plus h, you're taking a plus h, plugging it in to this expression, or this function, x squared plus 1, and you're going to have to FOIL it out. You end up with a plus h times a plus h. Final answer is a squared plus 2ah plus a squared plus 1. Okay, number 5. Here we have this type of composition of function. The way it's expressed is f of g of 5. So you want to rewrite it using the nested parentheses, f of g of 5. So we know we have to evaluate g first with the input of 5. So you plug in 5, you end up with 10 minus 4, which is 6. We take 6, and this is the input for f. So we take 6, we plug it in to this function, and 6 squared minus 3 times 6 is 36 minus 18, which is 18. Number 6. Here you have a graph, well actually two graphs, right? Two functions on the same Cartesian coordinate plane here, and they're asking what is f of g of 4. So they're basically asking for a composition of functions with the input value of 4. So g is first, so we start with g. We basically have to find where x equals 4, right over here, and we just go up and go up and go up and say, oh, okay. We stop where the line g is. So this right here, that didn't work again. Let's move over to, there we go, this one. All right. So now that we have our input of 4, we know that the output is the y value, which is 7. So g of 4 is 7. And this is the input for the outer function, which is f. So 7 goes in here. And what is f of 7? Well, we find 7 on the x-axis, and we run up until we hit the line, the graph, and here it is. What is the y value that's associated with this? It is 8. And that's how you solve this. Number 7, which diagram represents a one-to-one function? If you remember, the one-to-one function passes the horizontal line test, and the only one to do that is option 3. Number 8. This one asks us, what is the range of the temperatures during this interval? So, as you can see, we have an interval. We go from this point over to this point. There's no arrowheads. It's not going up or down forever, left or right forever. So this is a finite interval. So we know that range means y values. So what are all the y values represented in this function? Well, we start at the very bottom of the function, which is 64, all the way up to the maximum value of the function, which is 76. So basically, we're looking at the range being all values between 64 and 76, including 64 and 76. Okay? And you know you're looking at y values because look at all your answer choices. Every single one has the y in there. Okay? And this one is using the less than or equal to symbol. The answer is 4. Number 9. So this one asks for domain this time. So we need our answer in terms of x, whereas number 8 asked for answers in terms of y, the range. So here we want to find what are all the x values used in this function. So as you can see, we start with 4, and we go across, and we end with 13. So this bell curve looking graph or function consists of all x values between 4 and 13. This, ladies and gentlemen, is how you write that. 4 is less than or equal to x, which is less than or equal to 13. Number 10, all you need to remember is the golden rule of logarithms. You cannot take the log or ln of 0 or a negative number. So remember, ln is the natural log. It follows the same rule. So if you look at all your choices, yes, the domain, you're allowed to take the logarithm of all integers. All real numbers is fine. X is greater than or equal to 0. X is greater than 0. Sorry, I misspoke. You cannot take the log of all integers. That's not going to work, because integers includes negative numbers. All real numbers also includes negative numbers. We have to be in the positive realm. The question is, are we allowed to have 0? The only difference between 3 and 4 is that this is 0 is included. So as you can see, you cannot take the 0 or negative number, so 3 is out. The answer is 4. You could also graph this on the calculator, and you could see that here the graph shows that, look, it has a vertical asymptote. It approaches the y-axis but never reaches it. So we know that all the x values are greater than 0. This is the domain. All right, once again with number 11, graph all of your answer choices. Here's y equals 2. Here's y equals 2x. Here's x squared, our good old parabola. And here's y equals 2 to the x power, which is our exponential function. So they want to know which one is both one-to-one and onto. This one is not one-to-one because the horizontal line test would intersect infinite number of places. It's also not onto because there's many values left over in the range. Over here, this is our linear function. This one is both onto and one-to-one. Okay? This one is not one-to-one, and it's not onto either. And this one here is one-to-one because the horizontal line goes through one time, but it is not onto because all values below 0 are not used. The answer is 2. Number 12. This is a composition of functions, but also using an inverse function. So we have to start with the innermost parentheses. Remember, this is f of negative 1 of f of 2. So we start with f of 2. So we plug in 2, which is 2 cubed minus 5, which is 3. Then 3 is our input of the inverse function over here. However, we have to algebraically find out what the inverse function looks like. So if you remember, you need to take your function, y equals x cubed minus 5. We need to basically swap our x's and y's, which we did here, and solve for y. We add 5 to both sides. We end up with y cubed equals x plus 5. Then we take the cube root of both sides, and the cube root and cubed cancel out, and you're left with y equals the cube root of x plus 5, which is totally fine. And now we can take our f to the negative 1, basically the inverse function, plug in our 3 as an input. 3 plus 5 is 8, and it just so happens that the cube root of 8 is 2, because 8 is the same as 2 times 2 times 2. If you remember, to break out of cube root jail, you need a trio. 1 makes it out, 2 don't make it. The answer is 2. Now, let me show you a shortcut. What you could have realized is that we're taking the inverse function of a function. Your answer is always the input value, 2. And that's why when we did it the long way, we got 2 as an answer, but if anybody had realized this, you could have just said, oh, we're taking the inverse of a function, so the answer will be x, or in this case, the answer will be 2. Okay, here we're going to find the inverse of the function algebraically. You need to swap the x's and y's. So as you can see, I copied it down. I changed f of x to y notation. Y equals x over x minus 2. Then I switched it to x equals y over y minus 2. Now, pay attention closely. To get from here to here, I basically cross-multiplied. So x times y minus 2 is x parentheses y minus 2, and y times 1 equals y. Now coming up to here, I distributed xy minus 2x equals y, Now our goal is to get the y by itself. So I add 2x to this side. The problem is I have a y here and a y here. So this one's a tricky problem. I add 2x, I add 2x. I end up with xy equals y plus 2x. Then I subtract y from here, subtract y from here. I end up with xy minus y equals 2x. Over to this line. I end up factoring out the y. This is how you get the y by itself, really. So you have y times parentheses x minus 1 equals 2x. And now to get the y by itself, finally, in the final step, is to divide both sides by what's multiplying it, which is x minus 1. This cancels out, and we end up with y equals 2x all over x minus 1. Okay, the last two questions have to do with function transformation. If you remember, transformation, we learned about basically 4 or 5 different types. We have vertical translation, which is sliding up or sliding down. If you have plus a or minus a is a constant value, then that goes up or down. Horizontal translation goes left or right, but it's counterintuitive, meaning it may not make sense at first. So we have x plus a. When you add something inside the parentheses, you actually go in the negative direction, so it slides to the left. X minus a actually slides to the right. Then you have reflection in the x-axis. If the whole function is negative, it reflects over the x-axis. If only the x value is negated, then you're actually reflecting over the y-axis. And finally, dilation by a factor of a. This is what we talked about with the compression, right? Compressing means you're actually getting taller and skinnier, and expanding would be getting wider or stretching out, right? So when you expand, you're actually multiplying by a fraction, say 1 over 3. And when you compress, get taller and skinnier, you're actually multiplying by a number greater than 1. So if you multiplied this function by 3, everything would be tripled. All the y values would be tripled. X values are always the same. So, number 14. We want to translate the graph of y equals x cubed 4 units to the right. So I know if it's going to be a horizontal translation, 4 units to the right means minus 4 inside the parentheses. 2 units up is going to be plus 2 outside the parentheses. And that's why this is your final answer. Number 15. On the same axes, draw and label the graph of 2f of negative x. So basically we have 2 transformations happening here. We're doubling everything, so that's a dilation, and then we're actually negating all the x's. So I'm going to highlight the original function, and then we're going to perform each transformation a step at a time. All right, the dotted line is the first transformation, and by the way, it doesn't matter which order you go in. So we're going to negate all the x's, which we know is going to be reflection in the y-axis. Reflection in the y-axis. So basically, this point here is going to reflect over to here, right? This point here is going to reflect over to here, and finally this point here reflects over to here. Connect the dots, and here is the reflected function. And now all we have to do is double everything. Now when we double f of x, we're actually doubling the y values, right? 2 times f of x is really 2 times y. So every y value we see is going to be doubled. So this y value is 1, now it's 2. It's a different color here. Now it's 2. This y value is 0, we double that, 2 times 0 is 0, stays there. This y value is 2, it doubles to 4. And this y value is 4, and it's doubled to 8. And ladies and gentlemen, this is why this function looks, looks a straight line. And that's better. Good luck to you.